Good afternoon and welcome to Anaghomaths. I'm going to do a question that students have requested me to do. It's a very difficult question by substitution and it was in an exam paper. So 2025 paper, and it's a question number 13. It's on substitution. I'll go through the method. It's not something you can do in an exam if you haven't seen it before. So it's very important you watch the video carefully till the end and understand the method of substitution. Once you know the method of substitution, all you just do is just replace everything and start to integrate. So substitution makes it easier to integrate. That is why it is very important for those doing A-level mathematics to have done all the questions in the exercise or exercises in the textbook. So you would have seen this type of question. So let me jump right into it, and then I go through the process and you look at the steps. It's very, very important to follow those steps. There's pure mathematics, advanced level paper, 2025, 9 MAO. Total mark is 100 marks for that paper. The question number 13. Given that A is a positive constant, use the substitution x equals to a tan squared theta to show that this integral is equals to that. It's 4 marks. And then it says hence. Hence means use your answer from before. Use algebraic integration or without further substitution to show that integral of that expression gives this one. And P, Q are constants to be found. Total is 8 marks. This is 8%. So let's jump right. The first thing you do is you write x equals to a tan squared theta. You find dx over d theta. You differentiate x with respect to theta. The 2 comes in front, and there's the a there. And when you differentiate tan theta, you get sec squared theta tan theta. So it becomes 2a sec squared theta tan theta. And you can use your formula book. The formula book will show you how to differentiate tan theta. And then now we'll make dx the subject. Take d theta to the right. So dx is 2a sec squared theta tan theta d theta. Now, we want now to substitute. So we have to replace the x. You go into that original, you replace the x with that. So dx is replaced with 2a sec squared theta tan theta d theta. And then you replace x with a tan squared theta. Watch that red circle. Replace x with a tan squared theta. And this a stays the same. And this x, you replace it with a tan squared theta. Now that you got this expression, we need to start to simplify it. Factorize a out of the bracket. You have 1 plus tan squared theta. So what I've done here is factorize. And then we know that 1 plus tan squared theta is sec squared theta. So you replace 1 plus tan squared theta with sec squared theta. And square root of sec squared theta is sec theta. And then square root of a will stay as square root of a. So this is now your new expression underneath. Collect the like terms. A plus square root of a plus a. So there will be 2a and a to the half. So if we add it all, we would have a to the 5 over 2. So there's 2. And then a to the 5 over 2. A to the 1 plus a to the 1 plus a to the half. You add those 3, you get 2.5, which is 5 over 2. Tan squared times tan, it gives you tan cube. Sec theta times sec squared theta gives you sec cube theta. Let's replace the limits. Because we are given that x is equals to a tan squared theta, we put x to be 0. So 0 is equals to a tan squared theta. We solve for theta. So you divide by a. 0 divided by a is 0. Find the square root of 0. Square root of 0 is 0. So tan theta is inverse tangent of 0, which is 0. So when x is 0, theta is 0. This is where we are changing the limits. The limit was 0 for x. Now theta is 0. Now we want to use, when put x is a. When x is a, we have a is equals to a tan squared theta. We divide both sides by a. A divided by a is 1. 1 is equals to tan squared theta. Find square root of 1 to get tan theta. And then inverse tangent of theta. Make sure your calculator is in radians, is pi over 4. If your calculator is in degrees, you get 45 degrees. So you will change it to radians. So we know that we change from 0 to pi over 4. That's the limits. And we write the expression 2a to the 5 over 2 tan cube theta 6 cube theta d theta. And that is what they wanted you to change it to. And you could take the 2a outside, 2a to 5 over 2 outside the integral sign. And that's your 4 marks. The main thing here was differentiate a tan squared theta. And then replace 1 plus tan squared theta with sec squared theta. And then collect like terms and then change the limits. So that is the first part. You can screenshot this or you can write it down. I prefer you to write it down so you learn the method. And that's the next page. And that takes you to the final answer for it. Now for part B, it says hence. Hence means you use your answer from before. Use algebraic integration or without further substitution to show that. So what we want to do is, we have the original expression which we had changed. We change it to tan cube theta sec cube theta. So what we want to do now is, to do this integration, we want to factor out sec theta tan theta. This is a technique which you may not have seen before, but we need to get sec theta tan theta out. So we take tan cube theta, split it into 2, tan squared theta and tan theta. We take sec cube theta, split it into 2, sec theta squared times sec theta. So that will give us this sec theta tan theta, and that will give us this tan squared theta sec squared theta. The reason is because we can now replace tan squared theta with 1 minus sec squared theta minus 1. So we replace tan squared theta with sec squared theta minus 1. So doing that now, and then we have this new expression. Now we can put u to be sec theta, because it says we can use further substitution. U to be sec theta. Du over d theta is sec theta tan theta. You can get that in the formula book as well. Differential of sec theta. Now we take d theta to that side, and du is sec theta tan theta d theta. So now, since we got sec theta is u, so sec squared theta is u squared minus 1 bracket u squared, and sec theta tan theta d theta, all of that is the same as du. So we replace that with du. So we can see now what we got here is simple. and easy to integrate. Remove the bracket u squared times u squared, u to the 4. U squared times minus 1 minus u squared. Integrate u to the 4. To integrate, add 1 to the power, divide by the new power. u5 over 5 minus u3 over 3. Replace u with sec 5, sec theta. So that's sec theta, and replace u then. So your answer is 1 over 5 sec 5 theta minus 1 over 3 sec 3 theta plus c. But we don't need this constant of integration. I just put it there because it's a habit, because we have a limit, pi over 4 and 0. So we're going to sub in the limits. So we sub in pi over 4 and 0 in that integral. And now to simplify it, we replace theta with pi over 4 and replace theta with pi over 4. So sec theta is 1 over cos theta. So it's 1 over cos pi over 4, 1 over cos pi over 4 to the power 5 to the power 3. Put that in your calculator. It takes a while to do that unless you're very quick with the calculator. When you put that in the calculator, you will get this expression. Cos pi over 4 is root 2 over 2. Cos pi over 4 root 2 over 2. And then simplify this one, it gives you 4 root 2 over 5. When you do the whole thing, you get 2 root 2 over 15. Or when you put pi over 4. After that, you put 0, you simplify it, you get minus 2 over 15. This is where students make a lot of mistakes in exams. So when I mark the exam, most people make mistakes with this. But usually it's only like 1 mark at the end or so. So if you get up to this part, you should have got about 6 marks in that, or 7 marks. Now you put the 2 together. So the 2h power 5 over 2 stays as the pi over 4 value and the 0 value. Notice minus and minus becomes plus. And you put that together, you get 4 over 15 root 2 plus 4 over 15. So P is 4 over 15, Q is 4 over 15. So let's quickly summarize this part of the question. This part B, if you haven't seen this before, you would think this is impossible to do. That's why you need to practice lots of questions for A levels. Split that tan cube into tan squared and tan. Split that sec into sec squared and sec. And then from there, you substitute for sec theta. You can screenshot this page, screenshot this next page, and screenshot the final page. So hope that helps you with your practice for A-level questions. If you have any further questions, don't forget to WhatsApp me or send me a question on the link below, and I will do it for you.